All right, hey everybody, welcome back to our second example video of section 7.1. We're just going to be looking through this little example. So, recent study reports the mean age of tablet users is 34 years, standard deviation is 15 years, and we have a sample size of 100 people. Find the probability the sample mean, so keyword here is sample mean age, is more than 30 years. All right. So to do this, we need to go ahead and bring that into our normal distribution calculator. And for this, we need the sample sample average, which they give us, 34 years. But then we need the sample standard deviation. Remember, our formula for the sample standard deviation is here. It's the standard deviation divided by the square root of the sample size. So our sample size is 100. So the square root of 100 would be 10. So our standard deviation, 15 divided by 10 would be 1.5. And if you don't want to calculate that, or if those numbers aren't as easy to calculate, you can always bring that into your central limit theorem calculator. So what was our 34 average and 15 and 100? Okay, so 34 average, 15 and 100. And this should give us the same mean, and then the sample, the sample standard deviation, that would be what, 1.5 we said? And there we go. So 34 and 1.5. So that's what we use, 34 for our mean and 1.5 for our standard deviation. We take that into our normal distribution calculator. Remember, to get this, you can just type in normal distribution calculator. Top one pops up. And our average was 34 and the standard deviation of 1.5. We're calculating this between, what's the question? What's the mean? What are the mean and sample and standard deviation for the sample? Oh, so we already calculated that. So 34 and 1.5. All right, next question. What does the distribution? Oh, well, the distribution is going to be a normal distribution. Okay, here we go. Find the probability that the sample mean age is more than 30 years. All right, so more than 30 years means we're going to go above 30. There we go, 0.9962. So 99.62%. And our final question. Find the 95th percentile for the sample mean to one decimal place. And the 95th percentile means we're going to beat 95%, excuse me, 95% of the other people, or it's going to, the age is going to be older than 95% of all the other data. So 5% is above it, 95% is below it. So for that, we're going to type in our inverse normal distribution calculator. And we're looking for 0.95, an average of 4, standard deviation of 1.5. And take a look here. This is what a lot of you did on the test as well, which gives you the data to the right of this point. This would be, the shaded region would be 95%. And so this would actually give us the 5th percentile, the 0.05, 31.5. So to find the 95th percentile, we actually have to do the opposite. We have to type in 0.05. It's going to give us this value here on the right-hand side that would be 95% higher than the rest of our data. So 5% is on this little tail. So you have to kind of mess around with that. And remember that we're at 95th percentile means we're looking for the higher score. So 36.467. And there we go. They rounded it to 36.5. All right, that is our lesson on the central limit theorem. And next we'll move on to 7.2.